Welcome to The Explainer. Today, we're diving into a concept that, honestly, just completely bends the mind. We spend an enormous amount of time, and a whole lot of money, talking about how humans are building better AI. But what happens when we reach that inflection point where AI actually takes over its own development? Well, the rules of the game completely change.
So I want you to imagine a scenario. What actually happens when the intelligence we're building today becomes capable of building the next version of itself tomorrow? We aren't just talking about a faster coding assistant here. We're talking about the complete end-to-end automation of AI research and development. Seriously, what happens when an AI becomes its own software engineer?
Okay, let's dive into this. Because this idea, it isn't just some fresh Silicon Valley buzzword. The concept of an intelligence explosion was actually prophesied all the way back in 1965 by British mathematician I.J. Good. He realized a really simple truth. If intelligence is essentially a tool for creating better tools, then a sufficiently intelligent machine could just turn that tool inward. It designs a better machine, which then designs an even better one, triggering this massive, runaway positive feedback loop. And this brilliantly illustrates the sheer scale we're talking about. When we map this out like futurist Ray Kurzweil did, the trajectory is absolutely staggering. Notice how human progress, for pretty much most of history, traces a relatively flat, linear path. But computing power, it climbs dramatically, jumping by powers of 10. When AI starts self-improving, we completely abandon the incremental linear pace of human R&D. We jump straight onto an explosive exponential curve pointing directly toward the singularity.
To really grasp the magnitude of this shift, we have to look at the biggest bottleneck in our current system, us. Normally, you have human researchers identifying weaknesses, writing new training code, and publishing results. And sure, it's impressive, but our biological brains can only work so fast. Under recursive self-improvement, the AI is the one identifying the flaw, writing the code, and deploying the fix at the literal speed of computation. The human is entirely removed from the iteration cycle for compounding growth.
Section 1. The Anatomy of an Explosion. 3 Flavors of Evolution.
So how exactly does a computer program actually evolve itself? Well, a really fascinating paper from Google DeepMind suggests we can map this cold computer science onto something we already understand perfectly: biological and cultural human evolution. They argue that AI self-improvement will mirror our own human progress across 3 very distinct flavors. We've got genetic evolution mapping to AI changing its code, cultural evolution mapping to generating synthetic data, and cooperative evolution mapping to a division of AI labor. Let's zoom in on the micro level first. We have genotypic recursive self-improvement. Think of this as genetic mutation, but on fast forward. In biology, genetic evolution takes millennia, right? But an AI could self-modify its own DNA, its core neural architectures and optimization algorithms, in a matter of hours. It could even design the blueprints for faster silicon chips. This is your classic sci-fi version of an intelligence explosion, a machine literally rewriting its own brain to be smarter. The second flavor is mimetic, or cultural evolution. For humans, culture, our books, our education, our tools, drove our progress way faster than genetics ever could. For AI, culture is data. Think of a system like AlphaZero. It didn't learn chess from studying human games. It played millions of games against itself to generate better training data than humans could ever provide. An AI rapidly producing and learning from its own intellectual artifacts creates this massive, self-sustaining improvement loop.
Finally, we zoom out to the macro level, sociogenic or cooperative evolution. Human civilization exploded because we specialized. We didn't all try to be farmers, doctors, and engineers at the exact same time. DeepMind theorizes that superintelligence won't just be one single giant monolithic brain. Instead, it could be an incredibly efficient society of specialized AI agents working together, delegating tasks across a vast network, freeing up resources to hyperspecialize.
So the crucial point is, by doing this, the AI effectively creates what DeepMind calls a modular superintelligence, capable of parallel reasoning. This division of labor completely bypasses the physical memory and processing limits of any individual AI model. They network together, problem-solving on a scale we can barely even comprehend. Section 2. Speed bumps and bottlenecks. The reality check. Now, if all of this is theoretically possible, we really need to ground ourselves in present reality. It brings up a very specific, multi-trillion-dollar question. If this exponential feedback loop is so powerful, why hasn't this happened yet? Well, the sources point to some very real, very hard algorithmic and physical constraints acting as massive friction right now.
Now, what's really interesting about this slide is that the exact mechanism designed for self-improvement can actually cause self-destruction. This is a crazy phenomenon known as model collapse, or the curse of recursion. Researchers have mathematically observed that when generative models continually train on their own self-generated synthetic data, their internal representation of the world actually contracts. Instead of ascending to superintelligence, the model degenerates into this loop of low diversity and high bias. And beyond just the software algorithms, we hit the physical abstraction barrier. An AI might be able to dream up a brilliant, revolutionary new microchip architecture in milliseconds, but to test if it actually works in reality, it still has to be physically manufactured. Software can run at the speed of light, but empirical science, robotics, and global supply chains, they're stuck in the slow, linear physical world. That friction is a massive reality check and a huge speed bump.
Section 3. Guardrails. Managing the unpredictable.
Given the totally unpredictable speed of these capability jumps, how exactly is human governance attempting to prepare? Well, an affordance analysis of OpenAI's recent 2025 preparedness framework gives us a pretty clear look at current industry self-regulation. While the framework does track high-stakes risks like autonomous AI self-improvement, the analysis notes it actually encourages deploying systems with medium capabilities for severe harm. Plus, it explicitly allows the CEO to override internal safety recommendations, which really highlights how current voluntary self-regulation leaves some massive loopholes.
Section 4. The final invention. Let's move to and see how this builds toward the broader timeline. As we look past those current hurdles, where does this ultimately lead? The research group Epoch AI maps this out in concrete milestones. Step 1 is the creation of a fully automated AI researcher. Once human engineers are obsolete, Step 2 hits. The intelligence explosion is triggered. And this leads rapidly to Step 3, Artificial Superintelligence, a state where the cognitive gap between the AI and the smartest human is vastly greater than the gap between you and an insect. Which brings us to a final, rather provocative thought. The core logic of recursive self-improvement suggests an endpoint where the machine iteration loop completely closes. The moment an AI can do 100% of an AI researcher's job, human participation in technological progress effectively ends. So, in a post-singularity world where the machine is the ultimate creator, what exactly is the role humanity is left to play? It's definitely something we all need to consider. Thanks for joining me for this explainer, and keep questioning the future.